Everyone, welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 68 is on the screen. By now you should be experts at least 1, 2, and 4, I believe. And 3. I mean, 3 was a review, right? And hopefully yesterday's video sesh went okay. My bad, I forgot to include the home plate pages on Canvas, so sorry if you went looking elsewhere and you didn't find it and all of a sudden you were like, something's happening to me. No, it wasn't included. So it's a free day from me to you. But today, oh yeah, we got this. We got this. All right. It's a play sheet. It's going to be in the presentation, so make sure you copy the code once we get there. So I'll give you some time for that. Copy and go. All right, here we go. For the sake of time, I'm going to go over the warm-up since I was not here yesterday. Here it goes again. Number 1, complete the square and factor. Here we go. Well, that's not for you guys. All right, there it is. All right, so complete the square and factor. We got x squared plus 2x. How do we complete the square? Well, you take the coefficient of the second term, you add that at the end, divide it by 2, and then we square it. So therefore, x squared plus 2x plus, what is 2 divided by 2? 1. What is 1 squared? 1. We just completed the square. All right, how do we factor that? This one goes on top. That's my product. The 2 goes on the bottom. That's my sum. What 2 numbers multiply to give me 1? When you add them, give us 2. 1 and 1. So my factors would be x plus 1, or x plus 1 squared. Why squared? Because we just completed the square. Wow. Number 2, I'm going to go through this process for the sake of people that just joined us. Square root of -1 times square root of 121. That's how you break that down. Since there's no such thing as the square root of a negative number, we write that as an I for imaginary, because it's not real. So therefore, what is square root of 121? 11, so this is 11i. Hands if you got that by yourself. Yeah, by now we should be able to do that. Addition. We go with this plus that. I'm just going to put the plus here. So what is I plus I? 2i. And what is -3 and -4? That's -7. However, look up to the screen, since we are dealing now with imaginary, and this is a real number over here, we need to rewrite it. This becomes -7 plus 2i because it's a complex number. So far so good, yes? Subtraction. Same thing, but I'm going to put a minus here. So what is I minus I? 0, or they cancel. So then -3, and then the negative times the negative becomes a positive. So -3 plus 4, that is 1. That's my subtraction. Multiplication. I'm going to use distributive property. Erase this. Give me a second. I'm going to multiply. I times I is I squared. What is I times -4? -4i. What is -3 times I? -3i. What is -3 times -4? That's +12. So, if I was to simplify that, I bring down the I squared. -4i, -3i, that's -7i, and then plus 12. Let me zoom into that. Remind your neighbor, what do we write instead of I squared? What do we write instead of I squared? Yes, that is replaced by -1. So then I bring everything else down, -7i plus 12. I combine the numbers by themselves. What is -1 plus 12? That's 11. And then -7i at the end. And that is our complex number. And our favorite division, let's go. All right, let me scroll to the right. Long division. You guys remember that one? Yeah? Pretty good? You're like, oh yes, Mr. Q, bring it. All right, here we go. So we start with this one. I'm going to write, and I'm just skipping steps in regards to standard form because I'm assuming it is. So then it's I minus 3 divided by I minus 4. So here we go. It's an over. It's an over, guys. So here we go. What number times I gives me I? 1. That is correct. So 1 times I is I. 1 times negative 4 is negative 4. We subtract. We circle this to remind us to do what? Distribute and distribute. Some of you in your final, you forgot to do the second part. Some of you. So I minus I cancels. 4 minus 3 is 1. And that's my what? My remainder. So how do we write our answer for long division? Well, our answer is 1. Since we have a remainder, we put plus fraction bar. What goes on top? The remainder, which is 1. And what was our divisor? I minus 4. We good? Yes? Yeah? Kimberly over there, you good? Yeah? All right. All right. Shall we? With our favorites, let's go. So this was covered again yesterday in the sesh. So here it goes. For the sake of time, I'm going to go a little fast. What is the first thing we do? We change f of x to what? Y equals x minus 2 over 3. Next, we need to leave x by itself. How do we cancel that? 3 times 3 times 3. We're left with 3y equals x minus 2. Am I done leaving x by itself? No. Add 2, add 2. So we're left with 3y plus 2 equals x. Are we done? No. Let's make it the inverse. How do we do that? Switch the what? The variable. So we end up with 3x plus 2 equals y. And now we just need to rewrite it in function notation. 3x plus 2 equals f of x. Don't forget the negative 1 to remind us that it's the inverse. Let's go with this one. Change to y equals 3/4 x minus 2. We need to leave x by itself, so we add 2, add 2. We're left with y plus 2 equals 3/4 x. How do we cancel those 3/4? Tell your neighbor, how do we cancel these 3/4? All right, oh man, good conversations. Don, how do we cancel that 3/4? The reciprocal, which is 4 over 3 times 4 over 3. And the reason it cancels, technically it doesn't cancel, it becomes a 1, because 3 times 4 is 12. 12 divided by 12 is 1. So we're left with x. Distribute the 4 here and here, so we end up with 4y plus 8 over 3. And is that the inverse? No, we need to switch the what? The variable. So this is 3x, my bad, 4x. My brain is going faster than me. 4x plus 8 over 3 equals y. And then my inverse is 4x plus 8 over 3 equals f of x inverse. Too easy, right? Not too easy, it's tweezy. That's my word. Let's go. Yeah, tell your language arts teachers. I don't care. Copy the agenda. Here we go. Agenda for today, warm-up number 68, inverse functions. Today we're going to wrap this up. You guys know how to spit some rhymes? No? So you? Let's go. Brandon Doherty, let's go. All right, like the crack of the whip, I snap attack, front to back, in this thing called rap. Let's go. Bring it. Tonight's home play sheet 1.4 AD evens only. It's going to be included in the presentation today. Now, some of you were absent yesterday. I'm going to include a QR code for the lesson that you missed from yesterday, a bit. So copy this code down so you can have access to the home plate. DY3WJ, and for that one you need to go to Nearpod. Okay, and type in that code. That gives you access to the presentation for today. And last night's home play was pages 53, 54, and like I said, my bad, I didn't include those pages in Canvas, so it's free since it didn't match the, the other text. However, tonight's home play sheet 1.4 AD evens, looks like this. Woo-wee. And it's in the presentation. And there's your QR code. If you weren't here, get your phone out, scan that code. That's going to take you to yesterday's video lesson. Make sure you watch it so you can act like tomatoes. Let's go. And I got skills, right? Let's go. All right, get a Cornell note ready, and today's going to be practice. Make sure, those of you that haven't gotten your graph paper, you need a graph paper for today's session. It's in the back. Yeah. So our objective for today, I can identify and graph inverse functions, or the inverse of a function. Remind your neighbor once again in definition, what is a function, so that they remember what is a function. What is a function? And Brandon will enlighten us. Function. What is a function? Brandon Doherty, go. One input for each output. So it's a relation where for every input there's exactly one output. And remember when we did that introduction where I showed you guys the vending machine thingy where, you put $1, you pick the Gatorade red, and then you got a whatever. So anyways, we know what that is. So here goes this, because I sense a disturbance in the force because of yesterday's session. Here it goes again. Let me pause the tunes in the back. Here's a function. Doesn't matter what it is, but we are mapping -4 corresponds to -2, 0 to -3, 1 to 2, and 4 to 1. To make it the inverse, look up, look at the domain of the original, and look at the range of the original. Look at the domain of the inverse now, and the range of the inverse. Tell your neighbor what you see. What do you see in regards to the inverse? What do you see? Brandon, Darty, pass someone. Noah, what do you see? They're flipped. The domain and range are flipped. Or, here it goes, for those of you that didn't catch it, the domain is what variable? X. What is the range? Y. What do we do every time that we find the inverse on the warm-up, guys? We do what at the end? Switch these, don't we? Therefore, this, the Y, now came over here, and the X over here. That's why they switched. But now the Y became the X, and the X became the Y. That's all it is. And then from there, I showed you a second example. There it is. Domain, range, domain, and range. Questions, comments, autographs. No? At the end? Okay. Have you guys seen my autograph? No? Oh, here it goes. You guys got to see it. Wait, let me pause because I don't want people to steal my stuff. In regards to graphing, here's the relation. -4, 2, 0, -3, 1, 2, 4, 1. To make it the inverse, what do we do to each of these values, everyone? You flip them. So now we have -2, 4, -3, 0, and so on and so forth. That's why the black points reflect to the red points using Y = X. I gave you guys a second one like this. Here's the original points, which is this one, this one, this one, and this one. Do they look like if they are reflecting this way? Yes, using this line, which is Y = X. But where I want to get to is the funner one, this one. Oh, yeah, let's go. Look at that beauty. On a shirt, Q merch. Let's go. So I'm going to walk you through this one more time to make sure we got it. I've been giving you plenty of practice with the inverse, which is only this first column right here on the warm-ups. This is what gave you guys a little bit of problems. See what I did there? Problems. All right. So on your paper, on your Cornell note, copy this one, please. Example, Power Rangers Q, f of x equals negative 2x plus 3. F of x equals negative 2x plus 3. Don't copy the verbiage because I'm going to show you the process. F of x equals negative 2x plus 3. All right. So for the first part, you should be able to write this as an inverse. So show me the process all the way down just for the inverse. Do that yourself. We did it on the warm-up. Now I'm having you do it by yourself. First step, tell you never the first step just to get them started, please. What do you do first? What do you do first? Jacob, go. Oh, my bad. Oh, he's our guest right now. He's learning as we go. What do we do first? Yes, he said change this to y. Very good. All right, now that I got you started, finish off that inverse. I'll give you some time. Let me pause this really quick. All right. Good conversations. Walk me through the process, please. What's my next step? Danny, go. Subtract 3, subtract 3. That is correct. We end up with y minus 3 equals negative 2x. These cancel. Continue. Pass someone. Very good. That will be the last step. But before that, what do we do next? Jade. Divide by negative 2. Divide by negative 2 both sides. So we end up with y minus 3 over negative 2 equals x. And now, as Martin said, now we get to the point of flipping the variables. So my new variable, my new function is x minus 3 over negative 2 equals to y, but I'm not going to write y. I'm going to skip that step and write what? F of x inverse. So this is our inverse function. Write that in there. Inverse. Inverse. All right. So now that we have that, here goes the fun part. So for your home plate, look up to the screen. I think you have 4 problems where they're only going to ask you to find the inverse or write the inverse. From 1 to 5, how comfortable are you up to right there? From 1 to 5. Yeah, we got this, right? 5 fours, 5 fours, okay? The second part, they're going to ask us to graph this. So I'm going to skip to the graphing portion before I do the other one. So let's go to the graphing. So to the graphing, look up. I'm going to write this one. I'll go to your graph paper. I want you to write this one on the left. F of x, negative 2x plus 3. And copy that one in blue, by the way. Change that one to blue. So like that in our graph, we can distinguish the original to the new one. And our new inverse one is going to be f inverse of x equals, and let me zoom into this. Look up. I need to make this look like this. Look up really quick. Look up, look up, look up. I need to make this look like that. Write your utensils down really quick. Let me show you again. In order not to have a denominator like this, I need to figure out and see if this one has a number here. It doesn't. I put an imaginary 1. So therefore, that divided by that is my first part, negative 1/2. What's next? X. What's next? negative 3 divided by negative 2, because negative 1 1 divided by negative 2, same thing, negative 3 divided by negative 2. So therefore, I'm going to write positive, how many times does 2 fit in there? 1.5. So write that in there, please. This is our mu inverse function, mu inverse function. So here goes the graph, and the graph goes fast. I'm going to graph the blue one. Where do we start? Oh, we start here, Mr. Q. I'm going to use green for the y-intercept. What's my y-intercept, everyone? Positive 3. So you go to the y, go to positive 3. Here it is. Then you use your slope. What is my slope, everyone? Negative 2, but in fraction form is negative 2 over 1. That means 2 steps down, 1 to the right. So let me do that. 2 steps down, 1 to the right. Plot your point. Do it again. 2 steps down, 1 to the right. Plot your point. Do it again. 2 steps down, 1 to the right. Plot your point. Graph your line. So at this point, graph your line. Make sure you're using a pencil or a pen or something so your line is straight. Make sure you extend it as much as you can. Like so. All right, let's go to the red one. Where do we start? What's our y-intercept? 1.5. Where's 1.5? 1.5 is about, here's 1. 1.5 is about right there. What is my slope? It's a negative. That means it's going down. How many steps? 1 step down, and how many to the right? 2. Remember, the denominator is always to the right. So 1 step down, 2 to the right. So I go 1 step down, 2 to the right, and I plot my point here in between the 2 lines. Let me do it again. 1 step down, 2 to the right. Let me do it again. 1 step down, 2 to the right. And now we can graph our line in red. Once again, extend it as much as you can. Whoa. Now it looks like it's reflecting off something, so check this out. I'm going to draw a y equals x going through 0, straight through. Do the same if you can. Does it look like the blue is reflecting over here like the red? Look at this part. Is it reflecting over here? Yes. And this part? Yes, it's reflecting over here. That's how we know it's an inverse. All right. And last but not least, this is our inverse. Whoop, F inverse of x. And this one is our f of x. And this one I'm just going to label y equals x. Y equals x. All right? So that's the second part of the home plate. They're going to ask you to do that for, I think, 2 problems. You find the inverse, and then you graph it. However, the last part, which is the funner part, let's go. Oh, yeah, I like this next part. Here we go. Let me zoom out. All right. I'm actually going to do the work up here. So we're going to start with f of x. So write that on your paper somewhere. It's going to go straight down. And this is what we call using composition, which means we're going to check that they are inverses, okay? All right, so what are we going to check? So this is what we're going to check. Look up, please. We're going to check that f of x at the end is equal to x. However, we are going to substitute in here, instead of substituting numbers, we're going to substitute the inverse, f inverse of x. You're like, what? Yeah, it's cake. It's a piece of cake. All right? So here we go. Write this down, please. I'm going to zoom in. I'm going to go step by step just to make sure we got it. So we're starting first with f of x, okay? But instead of f of x equals to x, I'm going to write f of f inverse x. F inverse x. All right, so here we go. So first, I need to write f of x, whatever that is. So what is f of x, guys? Let's see. Let me zoom in. Isn't it this? I'm starting here. What is f of x? All of this. So let's write it. F of x equals negative 2x plus 3. Okay, so we started with f of x. However, what did we say? That instead of x, we're doing what? We're substituting the inverse for x. So this is where it gets funner. Here we go. I want you to rewrite this, but without the x. And for this x, write a big parentheses. Are we there so far? Okay. So what do we write here, Mr. Q? I'm going to write f inverse of x. All right. So here we go. Look up. What is f inverse of x? Yeah, we can use this one, but I'm going to use the original one. X minus 3 over what? Negative 2. So here I'm going to write what? X minus 3 over negative 2. All right? The left side stays the same because it's only telling us that we're working with the inverse. So let's write it again. The left side stays the same. And here, I'm going to distribute the 2 in here. So negative 2x times x, I'm sorry, negative 2 times x is negative 2x. Negative 2 times negative 3, that's positive 6. And all that over what? Negative 2. Bring down the plus 3. This last part. How we doing? All right? All right, let's go to the next step. The left side stays the same. Let's simplify this. Let's see. What is negative 2x divided by negative 2? 1x. What is 6 divided by negative 2? Negative 3. Bring down the plus 3. So, what do we have at the end? F inverse of x equals 2. Let's see, what is negative 3 plus 3? 0, and we're left with? Did we get what we wanted to see? Yes, f inverse of x equals x. There it is. If at the end you get it equal to x, that means that it is the inverse. Look at that beauty. Let's go. So that was only f of x. Now we're going to check f inverse of x. So over here, I'm going to write f inverse of x. F inverse of x. And what are we going to check? That f Inverse of x is equal to x at the end. But now, instead of x, what are we going to substitute? F of x. All right, so let's start off with writing our inverse. Here we go. What is our inverse? So I'm going to write F inverse of x equals x minus 3 over 2. The next step is what gets interesting. Do a big parentheses for x at the numerator, minus 3 over 2. But now we're going to write in here f of x. Question, what is f of x? Negative 2x plus 3. So we write that here, negative 2x plus 3. Okay, so, and the rest is piece of cake. The left side stays the same because it's only a label. F inverse of f of x equals, let's see, is there anything to distribute here? No. Can we combine stuff here? Yes. What is 3 minus 3? 0. And that leaves us with negative 2x over 2. Am I missing something? Oh, the denominator was a negative, sorry. Negative, negative, negative. My bad. All right. Here we go. F inverse of f of x equals. What is negative 2 divided by negative 2? 1, and that leaves us with x. Did we get what we started with? Yes. I think this is where we're getting hiccups right here, yes? This part? Are we good with the inverse, though? The first part? Okay, we're going to do another one of these just to make sure we get this part, not the graphing part. I don't want to take that much time with the graphing, and we'll go from there. So from 1 to 5, I'll come to Rory with the composition portion. 3, 4s, 5s, 4s, 5s, okay? Let's do another one. On your paper, copy this one, not on the graph paper. F of x equals negative 3x plus 1. F of x equals negative 3x plus 1. F of x equals negative 3x plus 1. And don't worry about the graph. I want us to get through the entire process of the composition. So here we go. We need to find the inverse first. So what do? Jacob, M. Yeah, you change f of x to y. So we end up y equals 3x, negative 3x plus 1. From there we solve for x. Minus 1 minus 1. We end up with y minus 1 equals negative 3x. What's my last step? Divide by negative 3, divide by negative 3. And now I'm going to write my inverse, which is y minus 1 over negative 3 equals x. Oh, my bad. This next part is the inverse. We switch these, so we end up with x minus 1 over negative 3 equals f inverse of x. You all right, David? All right? Yeah? All right. I think we need to up the tempo. Here we go. How about, did somebody, did anybody hear that? No? Anyways. All right, here we go. So let's do the checking. Ready? We're going to start with f of x. Look up. F of x. Okay, we're going to do this together a little bit faster. What are we going to check? Well, Mr. Q, we're going to check that f of x equals x, but instead of the x here, I'm going to substitute f inverse of x. Okay, let's go. So what's my first step? Well, my first step is to write this right there, just to guide us the rest of the way. So we write f of x equals negative 3x plus 1. That means that f parentheses equals negative 3, big parentheses for x, plus 1. So what am I going to write here instead of x, guys? What do we need to check? The inverse, right? So we write f inverse x, which is this part. Then what do I write over here? The second part, all this. X minus 1 over negative 3. Is it flowing a little bit better? Yeah? Yeah, a little bit better? You're like, okay, I think I follow. The left part stays the same. Remember, it's just a label. Equals. And now we're going to distribute this negative 3 on top. Negative 3 times x is negative 3x. Negative 3 times negative 1, that's positive 3. And all that over negative 3. Bring down the plus 1 at the end. We rewrite again the left side. F inverse of x equals. All right, here we go. What is negative 3x divided by negative 3? X. What is 3 divided by negative 3? Negative 1, and then you bring down the 1. Therefore, our last step, let's see, what is negative 1 plus 1? Cancel, and we're left with x. Did we end up with what we needed to check? Yes. So we did it now. We did it for f of x. Now what do we need to do it for? F inverse x. What do we need to check? That means we need to check that f inverse of f of x is equal to x. That needs to happen at the end. So what do we write here, guys, in this first step after we write our what we're looking for? Well, we need to write, instead of f of x and that equation, we need to write this one. F inverse of x. I'm going to show you the arrow. This one over here. X minus 1 over negative 3. So here's where we start with a substitution part. Big parentheses for x. Here we go. So instead of x, I write f of x. So what was f of x, guys? F of x is what? Negative 3x plus 1. That goes right here. Negative 3x plus 1. We already proved that one. Right? Am I right? Slow it down a little bit. All right, so the left side stays the same. F inverse f of x. Let's combine stuff on the numerator. What is negative 1 plus 1? 0. And that leaves us with negative 3x over negative 3. F inverse of f of x equals, what is negative 3x divided by negative 3? David. 1s. Did we get what we were checking for? Yes. From 1 to 5, I'll come to where you with that again, a little bit better. Okay, let's do another one. 5. You're like, bring it, Q. Oh, I got you. I got you. You know what? Let me change the slope to. Give me a number, guys. Okay, 5. There it is. All right. So, what do we do first, Jacob? Change y equals 5x minus 2. Next, solve for x. Plus 2 plus 2. Y plus 2 equals 5x. Next step, divide by 5, divide by 5. Y minus 2 over 5 equals x. But now we do the inverse, which is switch them, yes? So therefore, x minus 2 over 5 equals f inverse of x. So the next part is the fun part. You need to check f of x. What are we checking? That f inverse of x is x. And then the second part, you're going to check f inverse of x. And what do we check? That the inverse of f of x is x. And you do the process again. So we still have about 2 minutes left. You should be able to finish the whole thing, right? Do as much as you can, please. I'll give you that time. I'm going to stop the video right there. Once again, this is going to be uploaded on YouTube. Double check the process again to make sure you got it. If you need to revisit, make it a family math night or something. Tell everybody, gather around. Look what we learned today. Bam! We'll give you a happy meal. Anyways, I'll stop it right there. Bye.